Welcome dear students to ASA Original Engineering and Science Academy. Now, today we'll study very important application of the matrices. So in board exams, always the example is based on this. So solution of simultaneous equations using matrices. So already you know this. We can solve simultaneous, that is linear equations, by reduction method, which we have studied in 9th 10th standard. Then another method, that is the determinant method, that is the Cramer's rule. Now next methods we will study in the matrix. So by using matrix also we can solve the simultaneous equations. Now here in matrix there are three methods. One is the matrix inversion method, second is reduction method, and third is matrix method. So first of all we'll study how we solve simultaneous equation using matrix inversion method. So we'll consider system of equations a11x plus a12y plus a13z is equal to, suppose, b1, a21x plus a22y plus a23z is equal to b2, a31x plus a32y plus a33z is equal to b3. So these are the three equations in three unknowns that are given to you. Now you write these equations in matrix form. So Ax is equal to B. A is the coefficient matrix, X is the variable column matrix, and B is the constants matrix. So A means A11, A12, A13, A21, A22, A23, A31, A32, A33. Variables X, Y, Z is equal to constants B1, B2, B3. So from this, so A is equal to, we are getting the matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Now here you find A inverse by any method. Already we have studied how we find the inverse of the matrix. Three methods are there. One is the inverse by adjoint method, very simple method. Second, elementary row transformations, and elementary column transformations. So it is better to use adjoint method to find the inverse. So find A inverse. So after finding this A inverse, you pre-multiply A inverse to equation first. So this is the first equation. So A inverse into Ax is equal to A inverse into B. So A inverse into A into X, associative law, A inverse into B. So I into X, A inverse B. So identity law, X is equal to, we get A inverse B, and then by equality and taking the product of this A inverse B, we can get the solution of given simultaneous equations. So we'll solve example for this matrix inversion method. So solve by matrix inversion method. 2x plus y plus z is equal to 2x plus y plus z is equal to 0. 4x minus y minus 3z is equal to 20. So given system of equations, 2x plus y plus z is equal to 2x plus y plus z is equal to 0. 4x minus y minus 3z is equal to 20. Now we write in matrix form. So in matrix form, that is Ax is equal to B. Name this equation first. So A is coefficient matrix 2 1 1 1 1 1 4 minus 1 minus 3. X variable column matrix x y z is equal to 2 0 20. So therefore A is equal to matrix 2 1 1 1 1 1 4 minus 1 minus 3. Determinant A is equal to determinant. We will find A inverse by adjoint method. So 2 1 1 1 1 1 4 minus 1 minus 3. So 2 into minus 3 plus 1 minus 1 into minus 3 minus 4 plus 1 into minus 1 minus 4. So minus 2, so minus 4 minus 7 minus minus plus 7 minus 5 minus 9 plus 7, so minus 2 not equal to 0. Therefore A is non-singular matrix and A inverse exists. So as A inverse exists, so now we find the A inverse, so we will follow the adjoint method. So first we find out the transpose. So A transpose is equal to interchange rows and columns. So 2 1 1 1 1 1 4 minus 1 minus 3. Now you write determinant A transpose, determinant 2 1 4 1 1 minus 1 1 1 minus 3. Now you write the formula of adjoint. So adjoint A is equal to matrix Cij in determinant A transpose cofactor Cij is equal to minus 1 raised to I plus j into Mij. Mij is equal to minor of Aij. Now you know this for 3 by 3, for by this formula we are getting the signs of the cofactors alternatingly plus minus. So first of all we prepare the bigger matrix and the pattern. So plus minor, minus minor, then plus minor, minus minor we will write here, plus, so that afterward we will concentrate only on the minors. So signs are plus minus for 3 by 3 matrix. Now we fill minors. So for this two element, row and column gets cancelled. First row, first column gets cancelled. So 1 minus 1, 1 minus 3. For the second element, second column, first row gets cancelled. So 1 minus 1, 1 minus 3. 1 minus 1, 1 minus 3. While writing the minors, concentrate properly. So for 4 element, 1 1, 1 1. Now for this element, 1 4, 1 minus 3. 1 4, 1 minus 3. For this element, 2 4, 1 minus 3. And for this element, 2 1 1 1. For this element, 1 4, 1 minus 1. For this element, 2 4, 1 minus 1. And for this element, 2 1 1 1. So adjoint A is equal to matrix minus 3 minus minus plus 1, so minus 2, minus 3 minus minus plus 1, so minus 2, minus minus plus 2, 1 minus 1, so 0, minus 3 minus 4, so minus 7, minus minus plus 7, minus 6 minus 4, so minus 10. 2 minus 1, so 1 minus 1. Minus 1 minus 4, minus 5. Minus 2 minus 4, minus 6, minus minus plus 6. 2 minus 1 is a 1. So therefore, A inverse is equal to 1 upon determinant A into adjoint A. So determinant A is minus 2, so minus 1 upon 2 into adjoint minus 2, 2, 0, 7, minus 10, minus 1, minus 5, 6, 1. Now we will re-multiply equation first by A inverse. So A inverse into AX is equal to A inverse into B. A inverse into A, X is equal to A inverse into B. I into X, A inverse into B. X is equal to A inverse into B. So X means variable matrix, X, Y, Z is equal to, now A inverse minus 1 upon 2 minus 2, 0, 7, minus 10, minus 1, minus 5, 6, 1 into B means constant matrix 2, 0, 20. Now take the product. So minus 1 upon 2 minus 4 plus 0 plus 0, so minus 4. Minus 14 plus 14 minus 20, so minus 6. Minus 10 plus 20, so 10. So matrix X, Y, Z is equal to matrix minus minus plus 2, 3, minus 5. So by equality of matrices, X is equal to 2, Y is equal to 3, Z is equal to minus 5. So this is the solution. Now here we can check also whether this solution is correct. So by putting any two equations, if the two equations satisfied. So if you put in the first equation, so 2 into 2 plus 3 minus 5 is equal to 4 plus 3, 7, 7 minus 5 is 2, satisfied. In second equation, if we put 2 plus 3 minus 5, so 0, satisfied. Meaning of that the answers are correct. So this is about the matrix inversion method. Only the change is to find the inverse, you can follow any method. How do we fill out the command? That you can find adjoint method, or you can find elementary row transformation or elementary column transformation method. Thank you. In next period we will study the second method to solve the simultaneous equations.